Good morning. Myself Dr. Syamala, working as assistant professor in Department of Computer Science and Engineering in KL University, and now I am here to present a topic in the course Design and Analysis of Algorithm, that is Quicksort. So coming to the principle of quicksort. So quicksort can be solved by using the design technique divide and conquer. So in this let me explain the importance of quicksort. So by the name itself it tells that it is quick. So for example, given a list of n elements, so it is basically a sorting algorithm. So we will take a list of some elements, so n elements. We need to arrange the elements in some sorting order. So the process should be quick. So how the principle, how it is defined it as quick means, for example, you take that you are going to an exam. So in the exam you came early to the examination hall, and you are the one came 15 minutes before to the exam. So the invigilator who is there in that room, so can make you to identify where is your correct seat. So later, after 15 minutes, when the exam is about to start, all the remaining students enter into the room and they are struggling to identify where is their seat, and even the invigilator is not in a position to find out or to make them arrange in the order. So the students entering into the classroom will themselves recognize based on the one who entered the class first. So they've already known whether their number appears previous to him or next to him, so that they can be seated either in the left side or right side in that room, so that they can only check their seating position in the left side seating order or right side seating order. So there the person who entered into the class first is considered as the pivot element here. So first we will arrange that pivot element into the given unsorted list. This pivot after first pass using the quicksort algorithm is placed in its correct procedure, and then the elements that are lesser than the pivot resides at the left, and the elements that are greater than the pivot resides at the right. So this is the principle of quicksort. So we call this as quicksort because we can identify that elements are lesser than pivot in the left part and greater than pivot in the right part. So that's why it is called as a quicksort. So how to pick the pivot element in the quicksort algorithm? So there are multiple ways. So you can even choose that pivot element as the first element or the last element or some random element or a median element. So this quicksort algorithm applies the principle or the design technique divide and conquer. So we will first divide the given list into two halves. We will partition the given list into two halves, and then we will pick one element in this list as pivot element, and we will find the position of that pivot element, and then make that pivot element to sit in its correct position after one call to the partition algorithm, and then from the partition algorithm, that is after division and setting that pivot element in its correct position, we will return the position of that pivot element, so that it can take the left part as an unsorted sublist and then apply the same process of partition on the left subpart until all the elements in the left part get sorted, and then it comes to the right part, that is j plus 1 comma I, where j is the pivot element position, first pivot sorted element position, and then the same process is applied to sort the elements on the right subpart. So this is the process: divide, conquer, and then combine. So how it is being divided? So we will pick an element as the pivot element, for example the first element, and then we will partition the elements into two parts, that is first part whichever contains the elements lesser than the pivot, and the second part, that is the elements greater than pivot. So for this division purpose we will be writing an algorithm, and that algorithm is known as partition algorithm, and then we will recursively again call the same partition algorithm to sort the first part and then second part what we have obtained in the first iteration of the partition algorithm, and then finally there is no need for combine algorithm because in the recursive process itself we are sorting the entire list of elements. So this is the algorithm for quicksort. So the condition that we need to check initially is whether we have more than one element in the given list or not. So if there are no more than one element in the given array, so there is no need of sorting the elements using any sorting algorithm. So the input to the quicksort algorithm are the low value, that is the initial value, starting index of the array, and then high value, that is the end value, that is the last index value, index value of the last element. So we will first call the partition algorithm. So that is, we will make a call to the partition algorithm. That partition algorithm will choose the first element as pivot element and make set that pivot element is placed in its exact position, and also make sure that the elements on the left side of the already arranged pivot element are less than the pivot, and the elements on the right side of the already arranged pivot elements are greater than that, right? So again it will return the j value, that is nothing but the position of the pivot, where the exact position of the pivot, that is where it is already sorted. So we will again recursively call the same algorithm to sort the elements that are lesser than pivot, that is first half, considering low comma j minus 1, where j is the index of pivot, so it's already sorted. So we will be considering the element before to the pivot, so it is j minus 1, and this recursive algorithm will be called until we sort all the left subpart. Then a recursive algorithm for right part, that is j plus 1 comma high is called, and we will recursively sort the elements using the same partition algorithm on the right side. So what is this partition algorithm? So in the partition algorithm we will be having a low value and high value. Initially the pivot element is chosen as the first element, so it is taken as a of l, that is the low index value, and then j is equal to high plus 1. We have two variables I and j, I representing l low value and j representing high plus 1 value. That means the array, if the array contains 1 to 10 numbers, so we will take one more index, that is 11, we will be assigning a value infinity. So j is equal to high plus 1, so it is infinity. This j is pointing to the infinity value, j is pointing to infinity value. If I is less than j, that is the index of the starting index is less than j value, then only we can make have this process executed. That means I will make you clear why this y is less than j. So let me first explain the process of quicksort. So initially we will be starting with I is equal to 0. So that is the first index. So if I and j both are pointing to the pivot, so we need to make a comparison, right? So for that reason, first we will be incrementing the I value. So pivot is pointing to the first value and I is now incremented to the second index value. Then only we can make a comparison with this second value with the pivot value. So the procedure is here. So we will increment the variable I until we find that a of I is less than pivot. That means so pivot is greater than the elements on the left side part. So that means we will increment that, we need to make sure that all the elements on the left side of the pivot should be less than the pivot. So that's why, so for example, let me explain. Let me take an example and explain. Oh, sorry. For example, I have a list of elements like 50, 30, 10, 90, 80, 20, 40 and 70. So as told, As I told, so this is an array. This is an array containing how many elements? 3, 4, 5, 6, 7, 8 elements. So initially my pivot element is pointing to the first value, that is A of low, that is 50, and then my j value is I and pivot both are pointing to the low value, and j is pointing to j high plus 1, that is here it is j. The condition is the pivot element, so the pivot element is 50. So I need to check whether these elements, first elements, are lesser than pivot or not. So if they are lesser than pivot, you will compare first and then you will increment the pointer. So if it is greater, then only there is some objection. If it is not greater, there is nothing to object, right? So we will increment the pointer, and whenever we feel that some value from starting is greater than pivot, that means that it should not reside to its left, so it should reside somewhere to its right. So then we will perform some swapping operation with this I value and j value, right? So this is the process. Always remember that elements of this pivot appearing in the left side should be lesser. Whenever there is some bigger number, you need to perform some operation. So that we will see here. So initially pivot is the low value, and I is also pointing to low value, j is equal to high plus 1, and then you are writing the algorithm like while I less than j. So first you will increment the I value plus plus, so that I will be compared, I can be compared with the pivot element. So now I is pointing to the second position. So now you check whether if this A of I is less than pivot or not. So 30 is less than 50, yes it is true. Then you can increment the value of I. So now I comes here. So I is pointing to the value 10. So again you check it. So this is not if loop, this is while loop. So it should be iterated, right? So I plus plus, now I value is 3. So 10 is less than 50. Yes, this is also true. Again you need to increment the value of I. So now I comes to the index location 4, that is 90. So 90 is less than 50. So here the condition is failed. Yes, the condition is failed. Then you need to check one more condition. That means you need to make sure that this 90 should be moved to the right sublist. That means you need to check whether while after this A of j greater than pivot. Usually right side element should be greater than pivot, right? So if that is true, you need to increment the value, decrement the value of j. That means you need to push this j to its left. So before that, so initially j is pointing to infinity. So first you should make it pointed to the decrement the value of j. So that means now j comes here. So j is pointing to the index location 8, right? 8. So 70 is greater than pivot. 70 is greater than pivot. So is that true? 70 is greater than 50. Yes, it is true. So you can decrement the value of j. So now j will be pointing to value 40, right? So again it's a while loop, right? So 40 is greater than 50. Is that true? No, it's not true. That means it is a lesser value that is appearing in the right part. So that means you need to perform something. So what you need to perform? You have identified some value that is bigger than pivot on the left part, and you have identified a value that is smaller than the pivot on the right part. What you need to do? You need to swap these two values. How can we do that? So if I is less than j, so is index of I is less than j, you will check. So what is the index value here? 4. So 4 is less than 7. So is that true? Yes, it's true. So what you will do? You will swap the ith value with the jth value. So what is there in A of I comma A of j? That means we will get 90 here and then 40 here. Okay, 40 here. So I is pointing to here only, j is pointing to this 7th location only. Okay, so once after this, again you will be checking whether while I is less than j. Yes, obviously 4 is less than 7. We are currently at ith value 4 and jth value 7. Yes, this is true. In that case, again we will increment the value of I. So now I is pointing to 5th location. What is the 5th location value? 80. So 80 is less than, pivot value is 50. So is that true? It's not true. That means some value that is greater than the pivot element is residing on its left part. So that means you will not increment the value of I and then decrement the value of j first. Previously it is pointing to 70. Now j comes here. That is 6th location. Here now it will compare. So 20 is greater than 50. Is that true? It's not true. 20 is a smaller value. So at this position both the while loops of I and j gets failed. So that means some value greater than pivot is appearing towards its left and some value lesser than pivot is appearing in its right. So you need to swap these two values. So you will be swapping these I and j values. So using this if loop. So in that case, so you will be getting, so 20 here and 80 here. So this is I pointing location and this is 6th j pointing location, right? J pointing location. So now again it's a while loop, right? I less than j. So 5 is less than 6. Is that true? Yes, it's true. So we will be checking whether first we will increment the value of I before entering into this condition. So initial, now I value is 5. So it will be moved to 6. So 5 as it is. So I am writing I value here. Okay. So I value here. So A of I, so A of I means 6. A of 6 is 80 is less than 50. It's not true. So no need to increment I value. Now decrement the value of j before moving into that comparison. So I is pointing to 6. So decrement the value of j. So previously j is pointing to 6. Now if you decrement the j value, so it will be pointing to 5th location, right? So 20 is greater than pivot. Pivot is 50. Is that true? It's not true. So in that case, what you need to do? You need to check whether I value is less than or j. So in that case, you will compare whether both the values are residing as per the principle or any higher value appearing in the left. We will check here, right? Previously it's true, a bigger value appearing in the left. Yes, it's true, but now here we are failing this condition I is less than j. So we are violating that. So I value is 6 and j value is 5. So it's not true. So that means our list of elements are in the correct position only. In that case, we will stop this process. In this case, we will stop this iteration. That is, this condition also get failed here. I less than j condition also get failed here, right? So after that, so it means that we will complete one iteration, one process. See here, I less than j is failed. In that case, you come out from this while loop. So this is the entire while loop. You come out from this while loop and you need to swap pivot element with the jth value, A of j. So what is the pivot element? 50. What is the j value? What is the j value? 20. So 20 goes front and pivot comes to here. So let me write that. So 50, my elements are 50, 30, 10, 40, 20, 80, 90 and 70, right? So where are my I and j values? J is at 5th position and I is at 6th position. J is at 5th position. 3, 4, 5, 6, 7, 8. J is at 5th position. I is at 6th position, right? In that case, you need to perform the swapping of the pivot element with the jth value. So this means that you will be swapping 20, 30, 10 as it is. Then pivot element 50 comes here, 80, 90 and 70. So this is the end of the partition algorithm, and you will return the value of j. So I is here and j is here. So what is the value of j? What is the index location of j here? 5. So this will be passed to the partition algorithm. J is equal to partition of low comma high. Then this j will be passed into the recursive algorithm quicksort of low comma j minus 1. Then quicksort of j plus 1 comma high, right? So when this process, this algorithm, so this step is one iteration, one call was made, and we have placed that pivot element into its exact position. Now we have two sublists that are to be sorted using the same principle. So again we are recursively making a call to the quicksort algorithm. So by passing the index value from 1 to 4 in the left part and then 6 to 8 in the right part, right? So this will be called, and on this we will be considering this is the pivot element. We will apply the same process and we will make it sorted into its exact position, that is here, somewhere here, and we will get one more sublist here, left sublist and right sublist. We have the j value that is returned back to the partition algorithm. So based on this low comma j minus 1, again once again this quicksort partition algorithm will be executed and it will internally sort the sublist. Finally the resultant list contains the sorted elements. So this is the principle of quicksort. So here we don't have a merge or combine process, because internally we are applying the same process to sort the given list of elements. So this is the algorithm for swap or interchange. So the same algorithm what I have example what I have discussed, so that is explained with some other examples. So once after we make the pivot elements to its exact position, we have two sublists which are not sorted. Again the same process is applied here. Quicksort of low comma j minus 1 on the left side and quicksort of j plus 1 comma high on the right side. So coming to the time complexity of quicksort, so the best case and average case of quicksort is 2t n by 2 plus c of n, because we have a total three calls in an algorithm. One is partition algorithm. So partition algorithm is applied on n elements. So the time complexity taken to execute that partition algorithm is n, plus we are calling the quicksort by dividing the list into two halves, that is low to j minus 1 and j plus 1 to high. So that means the time taken to sort or to perform the sorting on these two sublists are t of n by 2 plus t of n by 2. So that's why it is written as 2t n by 2 plus n. So if you solve the equation by using substitution method, so we will be getting a time complexity as n log n. So this is the process of substituting that. So in the average case also the time complexity is order of n log n only, but in the case of worst case, so this worst case or bad case usually appears in quicksort when the given list of elements are already sorted either in the ascending order or descending order. In that case we don't have if you choose here the pivot element as 1, so we will get the time complexity as a t of n minus 1 only. So we will not make the quicksort algorithm to recursively call for 2 times, and for partition algorithm it is order of n. So the total time complexity taken to compute in case of worst case by using quicksort is order of n square. So this is about quicksort using divide and conquer strategy. Thank you.